Right, my camera keeps disconnecting, which is annoying me. Okay, so let's have a read. Right, Riddington. Come on, Greenock. Two small villages. Population for this one is has increased from 80 to 120. Population of the one has decreased from 200 to 120. Show that the population has had a greater change in Riddington. Show that Riddington has a greater change in its population. So show that the change in here as a percentage is actually bigger than it is here. Okay. So although this is changed by 40 and this is changed by 80, they're trying to show when you do percentages that Riddington has a bigger percentage change. So this is nice and straightforward to do. So to find a percentage, when it says percentage, the AGE is a fraction times 100. So if we go for Riddington first, we've got a fraction. Now the bottom of the fraction is always the original, so it's out of 80. It's changed by 40 people. This one I changed by 80. So this is 40 out of 80. Sorry, you can't see that. 40 out of 80 times by 100. Okay, and that is 50%. So you see that. Oh, not that one. Use your brain. So 50%. Okay. Then great, you got there. So fraction base was 200, and it was 80 people. That changed. So 80 over 200. 80 times that equals 40%. So you can see that it was definitely a bigger change for them. It was a bigger change by 10%. Okay, so there we go. We've shown that working out. So we showed it. Andy flies from the UK to Japan. I hope this is clear and it looks from my perspective. His plane ticket costs £540. And he then flies from Japan to Australia. His plane ticket costs 70,140 Japanese yen. The exchange rate is £1 to 140 Japanese yen. Layla flies from the UK to Australia. Her plane ticket costs 1,860 Australian dollars. The exchange rate is £1 Australian dollar to 0.62 pounds. Who pays more for the flight? Andy or Layla? You must show clearly how you got your answer. So we've got one price in yen, one price in Australian dollars. None of them are the same, so we need to get them to the same currency. So if we change them both to pounds, we can compare them. Wait. Oh yeah, okay. Right, I've actually read it. If I actually read the question, let me go back. So he's got the ticket that costs 540. It then goes from Japan to Australia, which is that. Okay. The other person goes directly to Australia, so UK to Australia. So there's just one ticket, which is that. Okay. So it's more complicated than it seems, but it's not too bad. So what I need to do is calculate Andy's ticket, because Andy went from the UK to Japan and then from Japan to Australia. Okay. So he's got 554. For his trip to Japan, and then he's going from Japan to Australia. So Japan was 70,140 yen. The exchange rate, remember what I like to do with exchange rates, we've got £1 equals 140, and I said if you're going into the other currency, you're multiplying, but if you're coming out of that currency, you're going to divide. So we're going from yen, this is your yen, to pounds, so we're going to divide by 140. Okay, which, if we do that on my calculator, 17 it's 501, so that cost £501. So if we add that together, it's going to cost £1,055 for Andy to go from the UK all the way to Australia, even though it's 2 flights, or using 2 flights. The other one, we need to look at Layla. she's got $1,860 Australian dollars. So we've got 1 Australian dollar equals 0.62. So we're going from dollars to pounds. Okay, so we're going to multiply by 0.62. Like that. Sorry, it just keeps getting lost. We're going from dollars to pounds. So because we're going out of that currency, we're going to do that here. So 1860 times by 0.62 gives me £1,153.2, which is obviously 20p in our currency. So using that, who pays more for the flight? Andy pays more. Sorry, Layla pays more. You could work out the difference with that one, but you don't need to. Okay, so there we go. So it's quite tricky because you have to read the question, and at the moment I think I'm like a coffee behind myself, if that makes sense. So I'm trying to read the questions, but I need to pay attention closely, and that's where I'm making my mistakes when I'm going through your videos. So he had 2 flights, Andy had 2 flights. One was in pounds, the other had to return it into pounds. So we divided by the currency exchange rate, and then we found his total cost. And then Layla just had 1 flight. It was a different currency, it was a different exchange rate. So because we were going from dollars to pounds, we multiplied by that, and we got that exchange rate. So it's on the scale of like exchange rate questions are quite tough. That's quite hard. Okay. Now I'm going to have a quick markup in terms of where we are. Assume I got them right. You know, it was like last time I got a few wrong. 1, 2, 3, 4, 7, 10, 13, 16, 24, 28, 32, 35, 36, 38, 41, 45. So if we were okay with it so far, 45 takes me to a solid grade 4. I'm definitely on grade 4. I mean, I need a few more to make sure I've secured it, but that takes me up to a good grade 4. Okay, so I was at 46, I think. Okay, now my advice to a student on this one is, first of all, just look. They're asking to plot any coordinates. I don't think they are. So without doing anything else, if they're not asking me to plot any coordinates, I'm just going to line best fit for this, and then I can use it. Okay, so it's got to be roughly in the right direction, roughly in the middle, like that. Okay, so that's my line of best fit. Okay, so Chicago is a city in the USA. Chicago is 4,000 miles away from London. By drawing a line best fit, it tells you to draw a line best fit, find an estimate for the time taken to fly from London to Chicago. Okay, so the graph clearly talks about how far you travel, how long it's going to take. So that's literally what it shows you. Okay, so we're going to go 4,000 miles, and then we need to estimate how long that's going to take. So 4,000 is there. That's why you need line best fit in. Go there and come down. Okay, so mine's sort of in between. So this represents 50. So each 2 of these are 10. So I've got 460, 70, 80, 490, 491 on mine, because it's just a little bit over 492 maybe. Okay, so I'm going to write that there, 492. Okay, so you got that, 492. I'll put that down. Why is your answer to part 1 an estimate? The reason is we don't have any values there, so I had to use the line of best fit. Okay, so it's because I used the line of best fit. Okay, right. Calculate the gradient of the line of your line of best fit. Okay, so gradient is a measure of steepness. Now they haven't asked you to do this on this before. okay, but they will actually do gradients in different questions, like straight line graphs and so on. So I'm going to go through the process, okay. So the idea of a gradient, it gives you a figure of how steep this line is, okay. If I'd have read it a little bit further, if I'd have been a bit more canny, I'd have read that I was going to do a gradient, and I'd made this line best fit a little bit nice for me to deal with, okay. So what I'm going to do is I'm going to draw a triangle where I think I've got roughly whole values. So I think I've got 50 this way, roughly, and 500 that way, using my scale. Okay. Now a gradient is the measure of rise over run. So it went up by 500 and it went across 50. So if I divide that with my calculator, I get a gradient of 10. Okay, that's what I get, that's my gradient. So the gradient of this line is 10. Give an interpretation of the gradient of a line of best fit. Okay, so what we've got on here, we have got minutes on the bottom, and we have got miles on the top, and in the end this is saying every minute we're going to go 10 miles. So every minute you travel 10 miles. That's what it means. Okay, that's the interpretation. That's quite tough for a first scatter graph question. Okay, but there we go. Right, I'm going to come down in difficulty now. Rotation, nice and straightforward. Okay, I hope. So we're going to rotate the shape clockwise, so clock goes this way around. So we're going to do that at 5-4. So let's mark 5-4. 5-4 is there. Okay, so draw my shape. Nice degree clockwise. It's a quarter turn like that. Okay, you can see the shape has gone 90 degrees that way. Okay, so I'm going to mark that off there. See, I'm just picking out my corners. There we go. And that is now T. Label it T, so I've done that. Next bit says, describe fully the single transformation that goes from T to S. So it goes that way. So we know it's a rotation because we just did it. We know it's 90 degrees because we just did that angle. But if I'm going back from here to here, instead of clockwise, it's anti-clockwise because you're going in reverse. So that's not a bad question, okay? And if that comes up, it's nice and easy to learn that you're going in reverse. Okay, this is forming and solving equations. So it's about applying our equation knowledge to a situation. So let's see how far we can go. See, can you read seagulls? I don't know if you can. Right, so all measurements are in centimetres. The area of rectangle A, area year 11, is length times width. So look at that there. So length times width is equal to the area, length times width, of B. So whatever the area of this one is, it equals that. So I'm going to put it in the middle of what I'm going to do because these two areas are equal. So the area of this is 4x times 2.5. So 4x times 2.5. Use your calculator, calculate for the number bit, but that is 10x. So 10x equals this area. Now this area is slightly different. You've got 7 times 2x minus 3. So that's 14x minus 21. But these are equal. Okay? So they're equal. Oh, yeah, that's right. Yeah, that's right. So what I need to do is solve x, and then I can work out this perimeter here. Okay, so I'm going to take away 10x, so 0 equals 4x minus 21. Then I'm going to add 21, so 21 equals 4x. Okay, lights go off again. So divide by 4, so x equals 21 divided by 4. Use the calculator, 21 divided by 4, which is 5.25. And that is x. That's just the value of x. That's not the question. The question is asking, what is the perimeter of B? Okay, so B is here. So the perimeter is all the way around, like that. Okay. So if I just sketch that out because I've made a mess of it, I've got 2x minus 3. These are 7. So that one, the one on the other side, sorry, you can't see anything. The other one's going to be 7. This one's going to be the same as this length. So I'm just going to figure this one out. So that's going to be 2 times 5.5. Take away 3. So put it in your calculator and you get 8. So this equals 8. So this will equal 8, the opposite side. Perimeter is where you add these up. So if I add these up, I'm just going to show my examiner that I know that. I'll get credit, that's 14, that's 16, so it's 30 centimetres. That's the perimeter of shape B. Quite a tricky little question. It was very awkward at this bit where you might not be happy with this bit where you've got 0 there. That's not always happening. So it's a really good question to practice. So I'm really happy with practicing this one now. Okay, right then. Tree diagrams. Before I even start working this out, right, I just want to remind myself what's going on with the tree diagram. Tree diagrams, the first thing I'm going to do is I'm going to multiply these fractions and then I'm going to add them depending on what I've been asked to do. So that's what I know I'm going to do in a minute. Okay, so this shows a 4-sided spinner, 3 A's and a B. The probability of landing on A is 3 out of options of 4 of them. For a B it'll be 1 out of 4. So you're going to spin this twice. This is the same spinner, so these fractions are going to be the same the whole way through the diagram. So that's going to be 3/4, that's going to be a quarter, that's going to be 3/4, that's going to be a quarter, because this is the same spinner. Okay, and like I said, we know we're going to multiply these fractions, so we're going to have 3/4 times 3/4, you're going to have 3/4 times a quarter, you're going to have a quarter times by 3/4, and you have a quarter times a quarter. Okay, that's what we're going to have. You can use a calculator, but I'm not going to. I'm just going to work these out. So 3 out of 16, 3 out of 16, and 1 out of 16. So there's my probabilities. Work out the probability that a spinner will land on an A on the first spin and land on a B on the second spin. A on the first spin, B on the second spin is 3 out of 16. And I've already done the hard work to do that. Okay, I'm going to stop it there, get some food, and do this when I get back.